Now, we are going to take up one more problem on cantilever, the problem number 8. It reads as, a cantilever of length 2 meters carries a UDL of 10 kilonewton per meter length over the whole length and a point load of 5 kilonewton at a free end. Find the reactions at the fixed end and draw the SFD and BMD of the beam. In these type of problems, you will not be able to get the figure, but you need to write the figure. So he says a cantilever of length 2 meters. So initially you have to write the cantilever beam, draw one horizontal line, and also one end is having a hatched portion, that is the one is the fixed end. And the length of the line is 2 meters. And a UDL of 10 kilonewton per meter length over the whole length. Since it is the whole length, so you have 2 meters. So UDL will be represented for the entire length of the beam. And a point load at the free end. So 5 kilonewton is acting at the free end at the point B, which is 5 kilonewton at a distance of 2 meters and from the fixed end. So this is how you will be able to get this figure, wherein you have an UDL of 10 kilonewton per meter for the entire length. And then you have a point load which is acting at a distance of 2 meters from A, is at the point B, which is acting downwards, which is 5 kilonewton. Find the reactions at the fixed end and draw the SFD and BMD. So when he is considering this, so here, first we need to find out the reactions at the fixed end. So what are all the reactions at the fixed end? We have the horizontal load, the vertical load, and the reactive couple or the reactive moment. When you are considering that, here, once as there is no horizontal load acting on the beam, so sigma h will be equal to 0. So that is sigma h will be equal to 0 as there is no horizontal load on the beam. That is RAH will be equal to 0. Now we will going to consider the vertical load. Since it is the vertical load which is to keep the beam in the equilibrium condition. So as the load is acting downwards from both 5 kilonewton and also 10 kilonewton per meter, which is acting downwards. So naturally the beam tends to bend in the downward direction. So in order to keep the beam in the equilibrium condition, I will going to require to have a vertical load which is acting upwards, which is RAV, which is acting upwards. So that is the summation of all the vertical load which is acting on the beam. That is the vertical load acting upwards and also the vertical load acting downwards will be equal to the vertical load acting upwards will be equal to the vertical load acting downwards. So that means sigma V will be equal to 0. So here we have the load acting upwards is considered to be positive. So that is by sign convention. Therefore, RAV minus 5 minus 10 into 2, because it is a UDL, uniformly distributed load. Since it is 10 kilonewton per meter for the entire span, which is going to be 2 meters. So 10 into 2 will becomes 10 into 2, which becomes 20 kilonewton, because meter and meter get cancels. So 20 kilonewton, and also the load acting downwards, which is 5 kilonewton. So 20 plus 5, but is minus 10 into 2 minus 5 will be equal to 0. Therefore, RAV will be equal to 25 kilonewton. So that is what we got it from here. Now we are going to take up the bending moment. So the sum of the sigma m will be equal to 0, taking the moments about the point A, the clockwise couple. The clockwise moment is positive. So the reactive moment, which is in the counterclockwise direction, it should be negative. So minus MA plus 10 into 2 into 2 by 2 plus 5 into 2 will be equal to 0. So naturally it should be 20 plus 10, which 20 plus 5 into 2, which is be 30 kilonewton meter. So MA will be equal to 30 kilonewton meter. So it will be in the counterclockwise direction, because as the load is acting downwards, so it tends to bend in the clockwise. So in order to keep the beam in the equilibrium condition, you have to have a reactive moment which is acting in the opposite direction, that is in the counterclockwise direction, which is equal to 30 kilonewton meter. So it is the counterclockwise direction. Now we will going to analyze with the shear force and bending moment diagram. So what is the shear force? So here the load is acting at the point at SF at B. If there is no load, then SF at B will be equal to 0. But since you have a vertical load is acting downwards, which is 5 kilonewton, By convention, the load acting downward to the right of the section is always positive. So SF at B will be equal to plus 5 kilonewton. Similarly, SF at A will be equal to plus 5 plus 10 into 2, that will be equal to 25 kilonewton, since it is positive, which is acting upwards. So here, SF at A will be equal to 25 kilonewton. So how it will going to be joined between the two? So as we see from the expression, as you see from the shear force diagram, you can see SF at A is plus 5 kilonewton. So from here, it is plus 5 kilonewton. And SF at B will be equal to plus 25 kilonewton. So from here, you take 25 kilonewton, then join between these two by means of a linear line, because the power of X in the UDL is W into X. So since the power of X is 1, therefore you will going to get a linear line between the point A, point B, which is 5 kilonewton, to point A, which is 25 kilonewton. So this is how you will be able to analyze the shear force diagram. Now what will going to be the bending moment diagram? So the bending moment diagram will be BM at B will be equal to 0. So we are starting from the free end, we are moving towards the fixed end. So what will going to be the bending moment at the point B? So BM at A will be equal to, so here as the bending moment is at this point, so you have the load into perpendicular distance. So as the load is acting downward, so the beam has to tends to bend in the downward direction. It becomes hogging. So by convention, it is negative. So minus 5 into 2, minus 10 into 2 into 2 by 2. So minus 5 into 2, minus 10 into 2 into 2 by 2. So on simplification, you will going to get it as minus 30 kilonewton meter. So when you plot this, you can see bending moment at the point B will be equal to 0, and bending moment at the point A is minus 30 kilonewton. So join these two by means of a smooth curve, which will going to be a parabolic curve, because the power of X in this condition, when you are having the uniformly distributed load from A to B, it will going to be always W into X by 2. So the power of X is 2. So since the power of X is 2, therefore you will going to get the parabolic curve. So this is how the line joining between the bending moment diagram at the point B, which is 0, to bending moment at the point A, which is 30 kilonewton meter, is by means of a parabolic curve. So this is how you will be able to solve this particular problem. Thank you.